Welcome back to Furuno Connections. In this episode, we continue our side scanning sonar testing as we move into some shallower water between 100 and 250 feet. We're doing that so hopefully the other competitor systems will be able to display something on their screen so we can compare it side by side with the DFF3D. Due to the fact that they run at higher frequencies, both of these systems seem to range out when you get it to about 250 to 300 feet of water, while the DFF3D still goes down to over 1,000 feet of water, showing both the bottom detail and fish targets. We start in 250 feet of water over a wreck so that we can show how each of the systems display their side scanning capabilities. We're going to talk to you about the DFF3D and how it works compared to the competitor systems and how they actually stitch together their pictures. Then we move into 115 feet of water over another wreck. We're going to show you the DFF3D side by side with System A and System C so you can see which one displays the fish targets and the wreck in the best detail so you know exactly which side of the boat to drop your line. Note that we were still not able to get System B's side scanning capabilities to work. When we first connected it, we were able to see the display and then it blanked out. And we tried everything we could to get it to work, but it still would not work. So unfortunately, we will not be able to compare that to the DFF3D.
So Captain, with the DFF3D, it's really cool with TZ Touch 3 because there's 4 individual modes you can display. And with TZ Touch 3, I can show them all at the same time. Really cool on the quad screen. For example, the triple beam downsounder mode or downsounder history mode, it looks like your traditional echo sounder you have, except in this case, you can look at what's 40 degrees on one side of the boat, on the port side, right under the boat, a 40-degree chunk, and a 40-degree chunk off to the right side of the boat. It's really cool. Then you have your 3D history mode, which is really informative, shows you what's going on, what you ran over. For example, we hit a wreck off to the side of the boat just now, we'd see a bump. You also have the cross-section mode and the side scan mode as well. So each one kind of is useful, but I really like these 3. The side scan mode is better for shallow water.
So Eric, your competitors seem to really push this side scan mode. What's up with that?
Yeah, I'll tell you why. If you notice, our competitors use a transducer that's basically juts into the water. It looks like a triangle when you look at it from the side. That's because they have to have transducers that point out down to the bottom. They actually literally point out. Well, we have a flat bottom transducer with the DFF3D that scans electrically. They can't do that. They have to use what's called a correlation system, which is a completely different technology and much simpler. That's why they can build it directly into their MFDs. However, when you have 8 individual transmitters scanning back and forth, it's a lot more sophisticated technology, which gives you more presentation information. With side scan, you can see that it's kind of difficult to use, and what they have to do, because they have 2 transducers pointed out to one side, 2 transducers pointed out to the other side, and basically nothing in the middle. They literally have to stitch this image together. While with the DFF3D, we electrically scan 8 elements with a flat bottom transducer. That not only gives you more information in real time and more information directly across the bottom, so we don't have to have this side scan mode, but it works at speed. If you notice with our competitors' products, as soon as you start to go fast, they have that transducer's got to stick down into the water, it gets turbulence and it washes out. Their systems can't work at speed, the DFF3D can. So if you have the transducer for the DFF3D in the right spot on your boat, like this yellow fin in front of the first step, or mixing it in with our combo transducer, where we put the fishfinder transducer and the DFF3D transducer in the same housing, you can run at speed and mark fish. It's really awesome.
So Eric, what I typically use the side scan for is when I tarpon fish.
Okay.
Because what we like to do is drive along those bridge pilings, and then I'll be able to see those fish, which hole they're stacked up in. Now what I used to do was I would take the boat and I'd drive in and out of each piling to mark the fish.
Okay.
With this, I can see them from afar without blowing them out.
That's right. You don't have to disturb them. You can see them and then go in and drop on them.
Absolutely.
Boom. Really nice.
Yeah, it's definitely upped our game in the tarpon world.
Okay guys, as promised, we moved inshore a little bit. Now we're in about 256 feet of water. So we're going to test System A, take a look at it in slightly shallower water where we definitely expect the performance to perk up quite a bit. We're going to see what we got here. So Cap Mike, can you tell us a little bit about the area we're in right now?
Yeah, so we came into about 250 foot. It's a pretty flat bottom out here. We're actually fishing a structure, a wreck, old sunken airplane, bits and pieces of it. But it's it's been out here for a long time. It holds really good fish. It marks very well, all the way from the bottom, all the way up into the water column, 100 feet off. So it's a really good spot. It holds quite a bit of bait, so it produces pretty well.
Okay, that's cool. So just to refresh everybody's memory, what we're looking at, we're using the same screen. We're just in shallower water. We're using System A's transducer that comes with the package we bought. So we're running down sounding at 260 kilohertz, and we're using side scan at 260 kilohertz as well. And let's see, it looks like we're using high chirp too. So we got all three items on the screen. We're starting to see some fish on the area Captain Mike brought us to. So we got some pretty cool targets right now, and it is looking a lot better. It seemed like being out in the 500 foot range just kind of max System A out for that kind of depth. But now that we're back in a little more reasonable depth of water at 256 feet, it seems to be picking up some pretty good targets.
Yeah, and Mike, we talk about detail when it comes to deep sea fishing, but when you get into shallower water, can you kind of reiterate the example or the advantages it has when you're in shallow water and you get more refined detail?
Sure. Oh yeah, it's huge, especially in the shallower. You start to come in a little bit. Some of these wrecks can hold 10 different species of fish.
Right.
So you get out here on an area, you start marking a bunch of stuff. You really don't know which is which. So just being able to clear that up a little bit for me, I can distinguish what fish is where, at what depths. And that also helps with what I'm going to be using for my gear.
And also with Side Scan Sonar, knowing where the wreck is on, either port or starboard side of the boat is going to help out a lot too.
100%. If because sometimes some of these fish, even though you got the wreck there, the fish aren't always around the entire wreck. It might be on just one side of that wreck.
Right.
So
I think we're kind of seeing that right now, that everything's on the port side.
Right.
All right, guys. So Captain Mike, in about 30 seconds, got us on some fish targets. And so, Mike, looking at the screen, we see it's off to the port side again. What are we looking at here?
So what we're looking at is we just kind of went over the wreck, and we're marking a lot of stuff off the wreck as well, which is really good. It just means there's a lot of stuff going on, a lot of bait. So kind of what we're looking at here is most of our fish are on the port side of the wreck, as you can see, and so everything that's pinned real close to the bottom, that's real tight, that's a lot of bait fish right there.
Okay.
All the stuff you're seeing that's kind of individual dots kind of hanging around the bait. That could be big AJs, that could be single fish, okay? And that's what's attacking these big bait balls in here, and that's exactly what you're seeing right here.
Okay, yeah, that actually looks pretty good.
Yeah, and there's definitely a lot of activity on there on the low end of the kilohertz spectrum, so...
Yeah, it's very busy.
Yep.
And we got nice solid bottom. That break there was just the turn we just made, so that's perfectly normal, and we see it's on the port side over here.
Sure.
I think we probably should drop a line in the water and take a look and see if we can actually, prove your point, Mike. See if that's really what it is.
Let's do it, yeah.
Fish are clearly on the left. We have our wreck right here, little piece of it. They're down here, and Mike dropped the jig down, and you can easily see right over here on the left side of our boat, he's hooked up.
Yeah, that's that wide beam.
Okay, what you're seeing right here is actually Mike's fish coming up. He's about 100 feet from the surface right there and coming up.
And we're gonna lose him. Yeah,
got about 100 feet, Mike.
Just came out of the beam. Yep.
Yep, just came out of the beam. Got him coming up. There he is, right there.
Yeah.
Got him. That's pretty neat to see.
So guys, one of the unique features I found in System A is the fact that you can choose from multiple frequencies, even on side scan and kind of down view. So what we did was we bumped it up. Previously we were using 260 kilohertz, and right now we bumped it up to 455 kilohertz. And like we talked about when we were out on the marathon hump where it was much deeper, depth can be frequency dependent. So now that we moved it from 260 kilohertz to 455 kilohertz, we're still at 255 feet of water, and we're noticing that while we can see bottom, we can't really see any fish at that high of a frequency at this depth. If we take a close look at the chirp screen, which is set for medium chirp right now, we have a good target, and it's just a teeny small target up here, and it's very hard to see on side scan at all. So once again, just proving the fact that you have to be pretty specific with your frequencies depending on what you're looking for and what depth of water you're in.
you know, we're out here in what, 250 feet of water. What are we looking at?
Yeah, so what you're looking at on the bottom machine here is going to be the wreck, a plane wreck that we're looking to mark and everything, and it shows it there.
All right. So what you're looking at on System C is we're looking at a 4-way split. What we're going to do is we're going to come in on the screen a little bit, and we're going to show you how we were able to mark this wreck and what we were able to see in about 250 feet of water on this down scan, side scan transducer.
All right, so yeah, this here on the bottom machine, that's going to be the plane wreck that we came out here looking for, marking it in 250 feet or so.
All right, Cam, are we seeing it on the other views here?
Not so much. You see it very faintly here, what looks like the down view.
Okay, so what we're looking at on System C is in the top left, we're looking at our side scan, and then we've got our down scan, we've got our high frequency sonar, and we've got our 3D here. What we're looking at is on side scan, we did not really pick up the wreck much here. You know, there's a little line of something we could see, but didn't really pick it up. On down scan, we have a little bit of relief off the bottom here. Still not a whole lot of detail. The most detail on this transducer is going to come from the high frequency sonar. We're seeing the relief off the bottom, and we're possibly maybe seeing a couple fish. The 3D out here at about 250 feet of water, you know, we're not really getting much detail, not really any usable information. Would you agree with that?
Yeah, definitely
Okay.
agree with that.
Yeah, like Cam said, we're in about 250 feet of water. You know, this may be getting to, you know, about the top end of the depth range that this is good for. You know, we tested it earlier in, you know, real deep, about 500 feet. We didn't really see much. Out here in this 250 foot mark, we're starting to get a little bit more detail, but not quite the detail that you would really need to find fish. I mean, Cam, would you be able to use this for every day out here in these kind of depths?
You know, these kind of depths, it's not ideal.
Okay.
Obviously, after what we've seen there, but it would get the job done if you had to get out here and do it. So
yeah. So
totally
if this was the sounder or this fish finder you had on your vessel, you know, you'd be able to find some stuff. Maybe not all the detail you would want.
This is the RV Thunderbolt, and you can tell right there on the side scan that the wreck was coming there, comes up and then goes down.
Look at this target separation on the bottom, fish and the target separation in that cross-section mode, and also in the 3D history mode how it's coming across, as well as the triple down sounder mode.
Yeah, the triple beam, you can
Triple
see
beam, yeah.
definitely
Yeah.
more on the right, and that tells you right there too, covered up. Right. All right, so right here, Eric, we're marking it up on our side scan Furuno sonar here, just like we are right here on the 3D machine. This is a great example that, you know, like this thing is marking it up. You know, so you can see it there, you can see it there.
You see it in two places, yeah. And like I said earlier, the side scan image works and the side scan display image works, but to me it's always been a little bit more difficult to interpret because this is side scan history and this is 3D history. The 3D history is just easier for me to picture in my mind how
Absolutely.
it looks. Our competitors use side scan side scan display image because they have to stitch the image together.
All right, guys, Captain Mike has got us to the shallows, and I know shallow is a relative term depending upon where you live. Up in the Chesapeake where I live, shallow is pretty shallow, 30 feet and less. But since we're out here in the ocean, down here it's about 115 feet where we're at right now. So right now we have 3 different frequencies going on the screen. In the upper left-hand corner, we have the down sounder at 455 kilohertz. In the lower left-hand corner, we have medium chirp. And then on the right-hand side of the screen, we have side scan at 260 kilohertz. So that's 3 different frequencies we're looking at, and we're finding some pretty neat differences between them, and they all have their, I'd say they all have their pluses and minuses. You guys disagree?
Yeah, no, I mean, you know, it's so interesting to see when we come into shallower water how much more performance, you know, especially on the side scan that you can see on the screen here. Yeah, no, I mean, to be quite honest with you, I'm pretty surprised at 260 kilohertz that it's still picking up this much detail at 116 feet of water.
Right, absolutely. So we're going to make one more pass over the wreck in shallower water. We're still in 116 feet. This time what we did is switched our frequencies up a little bit. We now have down scan at 455 kilohertz, side scan at 455 kilohertz, and medium chirp. And we just want to pass over one more time, let you know, or let you guys see what it looks like. and then we're going to move to even shallower water. And maybe Captain Mike can tell us what we're seeing here in this particular area.
Yeah, so what we're doing here is we're actually on a public wreck. It's called the Thunderbolt. It's a big Coast Guard cutter down there. And basically we kind of just went over the wreck. We're going to start going back over it again. But right now what we're marking is we're just marking tons of bait that's coming off this bottom right here. You can kind of see some of the structure of the wreck here. A lot of bait in the water column, some bigger fish in the bottom kind of coming up and attacking that bait. But yeah, it's I would say it's definitely not as clear as the lower frequency. I think we were marking a lot better with the lower one. Definitely on detail when it comes to the actual structure itself, the ship.
Right.
But yeah, it's we're marking heavy down there. A lot of activity going on.
Cam, where are we at now?
Yeah, so we've come in much shallower. We're sitting in about 100 feet of water, 110 feet of water. This is a pretty big structure. This is an old military ship, so we should mark it up very well here. Get a lot of good contrast from, you know, fish to the bottom to the ship and everything.
So being in here at 110 feet, we should definitely be able to see some good structure. Mark up some nice fish here on this down scan, side scan transducer. So we're gonna pop into the screen and show you what we're able to mark. All right, so we're looking at the screen here on System C. Same setup as before, side scan, down scan, our high frequency sonar, and our 3D. What we're gonna do is we're gonna look back here just a little bit. Guess we're not gonna go back. Here we go. Try and show y'all what we saw. So on the side scan, we were able to pick up the ship, and we were able to pick up these fish off to the left, which is real nice. On the down scan, we get a real cool image of this ship. We can see the stern, what looks like the bow, and we can see some of it on, it kind of looks like it's laying on its side a little bit, wouldn't you say?
Yep.
So on the high frequency sonar, this is where we're gonna see more of our fish. We're definitely picking up those fish in the water column. As you can see right now, drifting over what's probably, what do you think, school amberjack?
Yeah, you get some barracudas in this shot.
Okay,
also,
so this
could be some nice barracudas.
All right, could be some good sized barracudas. So what we're seeing is the shallower we get, we're able to see these fish on side scan. We're picking them up real nice on the down scan. Sonar's definitely showing them. 3D looks like it's actually starting to show us some fish. We're going to zoom in a little bit here on that 3D. So we're actually, the 3D is starting to show us some of that structure, and it's starting to show us some of those fish in the water column. So we're starting to get into a depth where that's going to become useful. So like we were able to see, the shallower we get with this side scan, down scan, it looks like the more information we're getting out of it. You know, definitely able to see a really nice, you know, column of fish. We got a really cool look at that wreck as well.
This is a great test to show the side scanning capabilities of each of the systems in a medium depth of water. System A did a pretty good job of showing the fish targets and the wreck structure when we were at 260 kilohertz, but when we switched it over to 455 kilohertz, we lost quite a bit of the detail. However, it is a pretty neat thing that you can choose from different frequencies when you're using that system. System C seemed to be stretching its capabilities when we were in 250 feet of water. However, when we got to the 150 foot mark and we were over that wreck, it seemed to find its place. With its higher frequency, it really did a great job of painting that wreck in high detail. However, the DFF3D still showed the fish targets clearer. Overall, the DFF3D still seems to be outshining the competitors in this side scanning sonar testing. Here in the mid-level water of 115 feet to 250 feet, the DFF3D just shows the fish targets clearer than it does in System A and System C. Make sure you stay tuned for the next episode where we go in shallower yet to about 20 feet to continue our testing.
Thanks for watching. If you enjoyed this video, make sure you like, subscribe, and click on the bell below to get notifications for the next time we release new videos. Thanks a lot, and we'll see you next time.